I believe I am live, I hope. Hello, and welcome to another installment of Jeremy humiliating himself on the internet. I'm practicing for interviews, I'm job searching, and I'm not great at interviews, so I am practicing a lot of them. Last week I did a video like this for Leak Code, and I performed marginally. I also need practice for system design interviews, and that's what this is. So, like the last one, if you watch that, I got a timer. I've got ChatGPT set up here to give me a prompt, so I don't know what it is ahead of time, just like a real interview. I've got my little handy dandy set of notes that I can refer to for how to keep myself on track, so I'm not keeping it all in my head. I've got Excalidraw queued up, which is a pretty cool diagramming library. This will be the thing that we create during the system interview. And obviously I'm not talking to a real human. ChatGPT is the next best thing. So I can ask clarifying questions and hopefully, more or less simulate an actual system design interview. So let's see how this goes. I am also not great at these, hence the practice session. So what I'm going to do is I'm going to start the timer, and then I'm going to hit enter for this prompt for ChatGPT to give me a prompt for a senior front-end engineer system design interview. So let's see where we go. 45 minutes and start. Okay? Boom. ChatGPT, what you got? All right. Ooh, a real-time collaborative editing system. All right. Imagine you are... Oh, hang on. Imagine you are tasked with designing a real-time collaborative editing system for a document similar to Google Docs. You should be able to simultaneously edit a document and see each other's changes in real time, communicate through a chat feature. As a senior front-end engineer, your focus is on the client-side architecture. Requirements. Real-time collaboration. Users should be able to edit the document in real time, and changes made by one user should be immediately visible to others. Okay? Show cursor positions and selections of other users in real time. There's a lot to get through for 45 minutes. Discuss a conflict resolution, communication, implement a chat feature. Wow, okay. Offline support. Consider the application should handle edits. Scalability. Discuss your design system to handle a large number of concurrent users. Performance. Address performance considerations, especially with dealing with a large document. Security. Ensure the security of the collaborative editing system, protecting user data and preventing unauthorized access. Deliverables, high-level architecture overview for a front-end system. Discuss the main components. Data flow, illustrate the data flow between client-side components and back-end. Technologies, suggest specific front-end technologies and libraries you would use to implement the system. Trade-offs, discuss any trade-offs you have to make during the design process, though there will be some. Considering factors like latency, consistency, and ease of implementation. Testing strategy, outline your testing strategy. Future considerations. Well, this is a lot for 45 minutes. I don't think we can possibly get through all of this, but we will give it a try. So the first thing to do for any system design interview is to ask for clarifying questions. So I'm going to ask, I got a few queued up here. How many daily active users are we expecting? Daily active users do we expect? Okay, well, this is not super helpful. Okay, so accommodate approximately 100,000 daily active users. Okay, maybe that wasn't such a helpful answer. How many? Well, no, that is helpful. I'd want to know how many we want to plan for in a given editing session. How many users should we plan for in a given collaborative editing session? Another crucial. Okay, updated. Approximately 20 actively collaborating in a single editing session. So not thousands. So that's a small scale. That's good. Okay, so let's talk about some constraints here. I've got a few notes to sort of keep me on track. Oh, this is a good one. What's a user persona we should be targeting? I'm just going to put this here just to save some time. Okay. Persona Alex. All right. Content creator or collaborator, marketing professional. Oops. Okay. Well, it's scrolling for me. It's very annoying. Moderately technical. Pain points, needs a seamless and efficient way to collaborate on documents in real time with team members. Experiences challenges with version control and async communication. So they really just want to work like Google Docs, really just like this thing. Okay. So I do want to know some other constraints. I could ask these all day. I think for something like this, we'd want to know, are there any Java? No, actually, no. I think I've got a sense of this. We will get into specifics like that. That's not a good use of time right now, though. So the first thing I sort of want to discuss with this is like what the overall architecture is. So for something like this, it's highly dynamic, highly rich. We don't want to have something that's static. It's very dynamic, so it needs, I think, something like a single page app is an appropriate kind of jumping off point. We'd want to just, I'm not sure if we're into framework discussions just yet, but I'd want to think about like kind of how this works. So maybe let's start with, just a core feature, right? So the first thing we want to do is, let's go over to ScalaDraw. Oops, that was OBS. So let's see, goal 1. Well, first we have to present a document, right? So before we get into things, I am broadly envisioning a sort of, this is what CRDTs are great for. I haven't used them myself, but it's a data, I think it's conflict-free resolution data. I forget what it stands for. Conflict-free replicated data type. It's a type of data type structure that enables concurrent updates across multiple replicas without the need for coordination between them. That's exactly what we need. I haven't used them, so this is going to be a learning exercise. So first off, let's see if render new or existing document. Okay, so first off, let's move this up here. I'm thinking, I don't want to get into the back end so much. It's not necessarily the point of this, but I guess we sort of have to. So browser. So this is going to hit a, it's probably going to go through a, whatchamacallit, it's not a reverse proxy, it's a, probably like a web application firewall, a WAF, I think is usually what's in front of servers. So I'm going to call this WAF, web application firewall, so that many browsers can't hit it. I'm going to copy this a few times. So, just a few more browsers here. These are clients. Them, oops, these, and they all hit the WAF. This will handle, no, this is more like a load balancer, I think. I think it's sort of similar. I'm going to Google later what a load balancer is, because I think I may be conflating these. This is sort of where my knowledge is limited. Boop, boop, oop, nope. 5. I haven't used ScalaDraw yet, but this seems like the perfect tool to use. Okay, so they're all hitting this. That's managing at any sort of, excessive traffic, IP block listing and all that sort of thing. And then that hits our application server, which is blah. Application server. Can I click this? And this is its own can of worms. Can I not center that? Oh, I see. Second. Okay, well, I thought centered in there. I guess not. Is that weird? Anyways, group these. Hang on a second. It's annoying me. There we go. Group these. Okay, and that goes to here. Cool. Boom. All right, so this is where a lot of the business logic happens. So this guy, all right, I think this will, just to do a high level overview of how it's getting the data, like this, probably, so we need some sort of like, the state of the document is updating very quickly. So this is performing business logic, and it's going to have access to some sort of a, what you call it? I'm thinking Redis, like Memcache or Redis, some sort of like data store that's very quick to update. So let's call this, I want to call it document caching storage. Cached document storage. This writes very quickly. It gets written a lot and then it writes through to some sort of cache. So that would then go through here. And then that would then persist data to a persistent storage, basically. Volatile storage and persistent storage. Let's call it, I don't know, MongoDB for now. Well, no, let's go with Postgres. I think it's a good jumping off point. Okay, all right, let me just move these over. I don't like how it doesn't grab everything. Okay, whatever. Boop, and boop. Okay. And these will basically, so when a browser tries to make an edit to a document, it goes through the load balancer to the application server. The application server does whatever business logic it needs to with the change. If necessary, it makes a change to the cache document storage, which is constantly being updated all the time because there's people working on it actively, and then it persists to the long-term storage on a slower basis for persisting it. So this writes less frequently than it. It's very read heavy, not very write heavy. So fairly basic structure there. Okay, so this should be enough at a high level to go fetch a document or create a new one. That's what would happen here. So let me just put this. Actually, no, I take that back. Business logic. This is really annoying. Oh, goodness. Hang on a second. Creates or updates document server side. Okay, that's fine. Whatever. Okay. All right. So that's what that's for. Business logic, storing it, persisting it. So from here, this is enough to just have a basic document. And as far as editing it, so we want to consider things like performance from the get-go. So in a document, you wouldn't want to send the entire document. You'd want to send diffs. So I believe that data transfer. Let's do this. How are we doing on time, by the way? Just want to bring that up. Okay. Data transfer. Where did I put that? Use. So I'm thinking that we'd want to communicate between. So take a step back for a second. We only want to communicate changes. A sensible way to do that is to use a diff of some kind. Off the top of my head, I think that something like JSON diff would be a good way of communicating changes as there may be. It's a library for basically showing what's changed in the storage of a document. So this actually brings us back to what is the data structure for a document? Off the top of my head, I'm thinking something like a big old JSON blob would make the most sense. Data format. Let's change this. Format, JSON. Data transfer. So we had also discussed security. So I'm thinking we could have encrypted JSON diffs backed by a CRDT. So that gets weird. I don't know. I'm not familiar enough with the CRDTs to know how that would work. So, okay, let's take this in phases. So the simplest case is we know that we want to update a JSON diff. Let's Google for CRDTs real quick. Conflict no. I don't know what that looks like. Optimistic replication. Okay, this is going to take longer than I have time to go over right now. So I will have to come back and learn about this because I'm going to need it for an actual interview. JSON diff CRDT encrypted. Within. Okay, this may not totally make sense. I gotta research this. I know these all play together somehow. We do need a JSON. We need to communicate diffs. They need to be conflict free, and they need to be encrypted. So somehow together that all needs to work. All right. So that is how these will all communicate. Now, as far that's how it goes. It makes the changes, and these also need to communicate to each other. So let's, can I, double arrowheads. Okay, I can't quite do double arrowheads, so, oh, wait, can I? Yes, no, I cannot. Well, that's a bummer. Well, these all belong to each other. Point, come on. 5, it's really annoying. 5. And just point back up to each other too. I mean, they all talk to each other is the point. The idea is when you make a change, so a change to a document contains the diff of the change, like you added the word the, or you added a space, or remove something, or swap something. It contains, let's talk about data structure. So, all right, so let's do this. Patch structure. So let's JSON diff based contains all right, diff of document change. This is going to contain cursor position. What else does it need? User metadata. It's annoying. Okay. Probably other stuff. That's enough to start with for now. So that. When any user makes a change, it's going to send an encrypted patch essentially. Okay, yeah. So the JSON diff will be inside the CRDT. It'll be encrypted before it leaves the browser, and then basically each peer will be able to decrypt it from a key that is provided from the application server. provides session tokens and encryption keys. Yeah. All right. It's just really annoying. Okay. So this provides an encryption key to each browser so they can all talk to each other, but anybody who's playing person in the middle won't be able to receive the data if they're trying to intercept it. So I'm thinking that this application server basically aggregates diffs. Essentially, just put a note here. Aggregates JSON patch diffs. To construct full document. Okay, I like that. It's basically like Git, essentially. Okay, so that's the patch structure. So essentially, I think we've got the basic building blocks for connecting. We can get into the details with all of these things, but we've got a system that will just send patches to each other because we're using a CRDT. It's okay if things are delayed or out of order. It should be automatically resolved. Getting into the specifics of how that CRDT would work is a bit beyond my understanding. I'll have to read up on that. But in theory, that should handle the conflict issues. So the way that these are all connected is that we want to have the fastest possible response time. The best way to do that is to have all these browsers connect directly to each other. So we would have we would use that WebRTC. So to do that, we need to have a stun turn server. So separate to this, I'm going to move this up here. Okay, because we need some more servers. Oops, bring this to here. Can I connect that? Oop, nope. All right, well, there it is. So what we need is a stun turn server. I'm going to put stun, because their acronym is turn server. So these also all connect to this guy. Oops. This guy. It's a little messy here, but the idea is that this stun turn server facilitates peer-to-peer communication in case one of these, any or all of these users are behind a NAT, then they can communicate with each other via a relay server, which is what the turn server is for. So that facilitates WebRTC. So basically, whenever a browser, whenever a user makes a change, let's write this out. When a user makes, okay, a second. When a user makes a change, change is converted to an encrypted, using the key provided by the application server, encrypted to an encrypted JSON diff. Again, I'm sort of guessing here. I'm reaching anyways within a CRDT. These may be incompatible concepts. I have to read up on it. 2. Change is sent to application server. 3. Change is sent to peers. So I'm thinking that this could be quite slow because like if it's doing that for every single like key change, it's gonna have to be debounced a little bit. Changes are debounced. I don't know, call it 500 seconds to 500 milliseconds. That way it's still fairly snappy. We'd have to tweak that a little bit. We want to find a good balance of like how, responsiveness and system load. I feel like we'd start with 500 milliseconds. 500 milliseconds as our baseline, and tweak it from there. Let's see what we're doing in time here. Okay, we have 20 minutes left. All right. So change is sent to peers. All right, so that should give us some interactivity and also update the document on the server side. I think that should be pretty good to start with. Let's go back to the prompt and see if we're missing anything here. All right, so let's cover, what does this cover for Alex here? Okay, I think that should cover this. And okay, collaborate with real-time members, good. Track changes, and I think that should roughly cover this. Okay, so now we need to focus on chat. So, interesting. For the chat portion of this, this would use a lot of the same functionality. So, I think that we could use, so this is for the document stuff. So let me draw a line around this. I want to do this, group this. Actually, before I do that, yeah, where did it go? Document data. Oop, nope. That goes back over here. And group it. And you connect to there. And we're also going to have kind of similar stuff. Really, like, I think that we could actually just copy and paste this. Chat data, because we want to have chat. I could say a lot more about chat because I built a chat app end to end, but that is not what we need to do. So chat. Cache chat storage and persistent storage. That would be, a data store for that would be, I think it'd also be good for Postgres because we can get into the weeds of it, but every message would be its own row in a messages table. We could dive into that, but let's not do that for now. I think it's not really the goal here. Oops, gonna bring this again, group these guys, group it. No, it's already grouped. Okay, well, anyways. Kind of a similar thing here. Same basic idea, but we have a distinction between our document data and our chat data. For the chat, so I don't know that we necessarily need JSON diffs for this. We're really just sending JSON messages. So let's go back up here, data document. Change this a little bit. All right, patch structure. Similarly, I'm running out of room here, but let's just go up here. Chat data structure, chat data format. I think also JSON is good for this. chat data transfer. Again, we want to use, we don't need the JSON diff. I don't even know if we need a CRDT. We will, I think we just need an encrypted JSON payload. I think that a CRDT might be a bit overcomplicating. The thing I'm concerned about is message order issues. So I think that for that sort of thing, I think we'd want to defer to the server to be the single source of truth. So what we could do, let's just do this, chat data structure, chat message data. I got a room here. Message content. We don't necessarily care about the timestamp because we care about when it's received, really. Like, no. Yeah, well, because the client could, we don't want to trust the time of the client. So we will defer to the server for that. Message content, user metadata. Okay, so this, I'm thinking, I'm wondering if we want to do this fully peer-to-peer, because that might complicate things. So okay, so here's a trade-off scenario. The fastest way to get a message from point A to point B is to go directly to point A to point B. What I mean by that is that this is point A and this is point B and vice versa. So if browser A, makes a message, it would have to we could broadcast that to each of the other browsers and then also to the back end, which would then persist it. But then you've got a problem of like race conditions, like messages may be received in order other than what they were sent, and then we have to sort of like reconcile that. It becomes really complicated. So I wonder if we necessarily need the fastest possible performance for that, and it'd be better to strive for, because we're not using a CRDT for chat, it might make more sense for to let the server decide. So I think that for simplicity, let's just send all messages to the server. The server will reconcile things and send updates back via WebSocket to the front end. Also, I should also mention that these are WebSocket connections rather than API calls. I'm not sure where to notate that here. Connections type. I'm going to put that. I'm actually just going to put that here. Connections. WebSocket for client server connections. WebRTC for P2P, client P2P. We'll be using a mixture of these things. Also, WebRTC is nice. Ooh, you know what? I don't know if WebSocket is encrypted by default, but I still think that we may not need to encrypt things. I gotta check on that. I can't remember if WebSocket automatically encrypts things the way that WebSocket. I can't remember if WebSocket encrypts things the way that WebRTC does automatically. With WebRTC, we don't have to worry about the encryption. It's built into the standard. Okay, so back on this, the chat message data structure. Okay, we have that, and then gets sent to server for reconciliation, and then echoed back to clients. It's getting a little bit hard to read here. Okay. Alrighty. I think we have a pretty good start here. Let's go back to our prompt here. Okay, ensure version control. Interesting. So a nice thing about using, so I'm kind of thinking of how Git handles repo management with, so basically a Git repo is basically just an aggregation of diffs, which is kind of what we get here. So we could actually get versions. I don't know that we want to have a version for every single change. That gets a bit ridiculous, because then you have like just unmanageable amounts of changes. So we need some way of identifying, like breaking up into chapters somehow. I think a simple way to do that from a design perspective would be to just have an arbitrary, like a debounced set of changes, like say every 5 minutes. So let's talk about versions for a second. Versioning. So this is at the application layer. So we don't want a version based on every single diff. We want to create a new document version. Edit a bounce rate of every, I don't know, 5 minutes to start with. Okay, I'm trying to think about how we'd want to persist that. Persisted storage, let's also expand this out a little bit. Nope, never mind. I'm thinking, let's add to this a bit. Document content. So this is another, these are like tables, I guess. This is kind of a, let me see if I can actually do this. I'm gonna use a circle to represent like a poor man's version of a table. Document table. No. So I'm trying to think, I'm envisioning something like Git tags. Like, you know, it's all just patches, but you can arbitrarily kind of tag it at certain points. So it would be probably a table of patches, patch table. Let's call it a tag table. Why not? Let's just go with the Git terminology. Yeah. I think that needs some more development, but that's sort of where my head's at with how we track versions. Then that would be communicated from the back end up to the front end with, well, I'm not sure how that would work exactly, but we present the versions and those would be associated to specific, we present the tags, which is basically a version to the user's perspective. Let's see, presented as versions to user. Cool. All right. I think that's pretty good. Let's draw some arrows here. Nope. The skeleton draw gets me with that. Okay. So we've got the patch table and the tag table. Where could we go from here? This is where it'd be helpful to have an actual person, because I could like see what they're curious about digging into specifically. So let's go back to here, see what the actual requirements are. Future considerations, robust version control, and change history. So I think we have a high-level way of covering that here. We could dig into it. We discussed chat a little bit, so that's going to go through WebRTC. Cross-device compatibility for flexible work environment. Because this is web-based, I think that we sort of get that kind of naturally. So we would want to have, so another thing to consider is maybe changing the experience a bit for mobile, because I think trying to have, even just from a user experience perspective, this would be really weird to do on mobile. Like, I guess you could, but Do we want to support all this functionality on mobile? I think that we do, because users would just want to do that. Chat gets weird, so in any case, the UI would be the UX notes here. Web-based, obviously. Responsive. Design so that, like, basically, like, a chat wouldn't necessarily show up. It would. This whole Google Docs would be, like, really crammed on a tiny little screen. So I don't know that we need to. I mean, you can get into specifics of that, but this is more architecture based. So web-based responsive design. Consider limiting functionality on mobile. And the reason for this is that it may just be kind of hard to present this in a usable way. So we may want to just come back to that. So I got some notes here. So I'm not sure how much these quite apply. Let's go back to the prompt. Okay, I want to go back to the top here. Offline support. Interesting. So this is nice because the CRDT really helps us here. So let's go back to Excalidraw. Offline support. It's getting a little bit crazy here. Offline support. Some notes here. So I'd want to use IndexedDB to store these data, to store document data. Okay, so first off, we build it as a PWA. It's installable PWA. Doesn't need to be installable, actually. No, it does. Not necessarily installable, but it does need to have a service worker. Service worker for offline functionality. We need to have indexed DB for client-side storage. Really just for offline storage. Okay, so basically I think that the CRDT-ness of the data transfer would enable, like, having a bunch of batch updates and then sending them to the server or to the peers and then having them reconcile it. Also for conflicts, oh no, for offline. Okay, so conflict resolution. Don't want to get into that. I just want to add a note for conflict resolution. Conflict resolution, mostly resolved with CRDT. The server application, server side business logic breaks ties. Breaks any. Is tiebreaker. There we go. All right, back to the prompt. Scalability. So we know that the scale we're designing towards is about 20-ish people, and I think that what we have would really cover that. This would really change if we wanted to have something that was massively scalable. So for instance, I think that we could consider, we need to consider degradation, essentially. Some functionality would not quite work at a massive scale. Basically, the whole thing breaks down after a while. If there's, say, 1,000 people viewing a document, I think that we could do things like disable chat. We could disable writing. You can make it basically read-only. Scale. Let's put this down here. Scalability strategies. Degrade functionality for busy documents. Hang on a second, I want to drag this over here. New joiners get degraded, get read-only access. That way, this defers processing, conflict processing. Not conflict processing, but resolution, shall we say, to server. In fact, I'm going to just there. Okay. This is getting a little bit hairy here. Other scalability strategies. Let's think about, as far as the front end is concerned, yeah, we can only have so many there we go. Don't establish P2P web RTC connections beyond, call it 25 users, just to give some headroom. It just defers back to the server essentially for all things. So that actually calls into question, we would then need to have this functionality. No, I think we kind of have this, because this would basically, browser communication would be an enhancement. Where do we have connections? WebSocket. This is an enhancement, basically. Okay, I'm out of time. I'm just going to wrap this up. Enhancement given for lower scale. Okay, so, well, that was frenetic. Let's zoom out for a second. Look at all that. I wrote a bunch of things. Oh boy. Here we go. So that is how I would handle a system design interview. Let's see how far we got with the prompt. I feel like we did pretty good at this. We talked about, we covered encryption, performance, and scalability. We considered offline support, communication. We had that for chat, conflict resolution, real-time collaboration. We didn't discuss cursor positions. I think we sort of touched on that by having that in the JSON patch. It's all very high level. We talked about some trade-offs. I think we discussed some technologies. Yeah, Postgres. We didn't get into front-end frameworks or anything like that. Talk about data flow. We did not cover the testing strategy. That's something we didn't have time for, or future considerations. So I think that's pretty good. Maybe not perfect. I feel pretty good about this. Yeah. Well, if anybody watches this and thinks has thoughts about how I did, please let me know. I'm looking to get better. If you have any tips or tricks, please share them in the chat. I will see them when I see them. But in the meantime, thank you for joining me. I feel a bit more confident with this stuff. It was kind of fun in a way. It seems a little bit ridiculous to sort of cram this sort of session into 45 minutes because it's so high level as to be a little hand wavy, but I know that I need to research CRDTs. I need to research how those can work with JSON diffs, and because I feel like I didn't really know what I was talking about in that regard, and I think that's going to come up in an actual interview, so I will learn more about that. But in the meantime, thanks for watching, and I hope you all have a lovely day. Bye.